your last stuff, though. The classic projectile motion problem. Let's make that 30 meters per second at an angle of 37 degrees. So it's going to be projected, the ball's going to go up and out and then eventually come down and hit at some distance R away from the base of the cliff. And the question is, how far from the base of the cliff does the ball land? Assume that the ball is being projected from the edge. So, while it is in the air, what is the direction of acceleration?
Down.
Why?
Gravity.
I'll nitpick that later. All right, yes. Force due to gravity. Down is defined by that direction. So because acceleration is downwards, we need to break this up into, well, things in that direction, or vertical and horizontal. So let's establish our conventions here. What do you want to make the positive directions?
J hat to the right, I hat up.
Okay. Feeling rebellious?
Is that how the opposite of how it's normally made?
Usually I hat is, if you're doing horizontal and vertical, I hat is horizontal. There were a number of people in the 151, they had a quiz, I think it was, where they did that. There were several of them who did that. It's not inherently wrong, so we can go with it.
Yeah, it is what you say it is.
That's right. Except for this problem, I guess it's what you say it is. All right, so we're going to break it up into those components. And again, there is going to be a recurring theme of, if you can figure out the direction of acceleration, then you want to put one of your unit vectors parallel or anti-parallel to that, and the other one perpendicular to it. So it's a motion problem.
What do you mean by anti-parallel?
Opposite directions.
Oh, okay, yeah.
Along the same line as opposite. So I have displacement, initial velocity, final velocity, acceleration, and time. And I will have my J hat and my I hat. So what do we know?
Well, the I hat acceleration from gravity would be constant.
Okay, let's put this on Venus. Acceleration due to gravity on Venus, about 8.87 meters per second squared. I used this in one of the other classes, so that's how I remembered it. It's not something I'm expecting you to remember. If you need it, I would give it to you. Sorry, if you need it on a quiz or test, I would give it to you. If otherwise, if it's a homework problem, I'd assume that you'll just look it up. If you type in little g space Venus, it's going to be this thing that pops up. So what is my vertical acceleration then?
Oh, go there. No, I've been talking all class.
All right, Benjamin.
Negative acceleration, that'd be negative 8.87 meters per second squared.
Yes. Thank you for catching the negative. All right, what else do we know?
Well, the gravity or force on the other axis should be 0, right?
Yep. Because we're concerned about once it's in the air. Once it's in the air, acceleration is constant. So if we're worried about it actually touching the ground or how it's getting launched, that's a different acceleration problem. So it is indeed 0 meters per second squared. We know 2 other pieces of information without doing anything too sophisticated, or 1 other piece of information without doing anything sophisticated.
J hat initial velocity is 30 meters per second.
No. Because that 30 is at a 37-degree angle. We're gonna
Yeah.
need to break it up. We can do that now if you want.
The initial displacement would be 0 for both.
This is the overall displacement, so at the end of the problem,
40 meters for J hat. I had, excuse me.
I messed us all up there.
Shouldn't it be negative?
yes, and negative. If you did positive, it's possible that you'll get a negative under the radical, which indicates something. So negative 40 meters. I don't have to put the I hat, it's right there. And horizontally, R. That's what we're trying to find. All right, so let's deal with the velocity. I have 30. Oh, I just wrote black on black, that works really nicely. So I have 30 meters per second at a 37-degree angle. Because of our coordinate system, we need to break it up. And again, that's another recurring theme. Once you figure out the direction of acceleration, you determine your coordinate system. And once you have the coordinate system, that tells you what you need to break up. In this case, we have only 1 vector to break up initially. So how much of that is horizontal? How much of that is vertical? So which is, how would you solve this one?
Vertical would be 30 sine of
Yep.
37. And the other one would be 30
Preferably
cosine.
degrees. Pardon?
The other one would be 30 cosine of 37 degrees.
Now, I am expecting both of these numbers to be positive. If you do plug into your calculator and you got a negative number, you might want to check if you're in radians instead of degrees. And so this one should be around, I think, 18 meters per second, and this one is somewhere around 24 meters per second. It's one of the reasons I picked 37 degrees. 3, 4, 5 triangle-ish. But if you use a calculator, you come out with 18.0 something and 23.9 something. We'll just take my word for it. Like, I was thinking that you had just done it, so that's why.
Oh, I did the first one. Let me see. 30 cos 37, 23.95.
And the other one?
I got 18.05.
I think I've mentioned this before. I mentioned it in one of my classes. I had done this where I gave the angle out to 10 decimal places, just so that it would come out to 24 and 18 or something like that, just so that it'd be perfect. But some students in those situations would round off the angle and come out with an imperfect breakup, if they wouldn't do the extra work. All right, so horizontally, my J hat, we've got 24 meters per second. And I hat, we have 18 meters per second, or I'll just parenthetically 18.05 meters per second, and 23.95.
Or 96, sorry, it's 9590.
96. Perfect. All right, so we pulled everything we can out of the problem. Now we actually have to do some more sophisticated math than just the right triangle trig. The one thing, just as before with the horizontal shoot, but we'll have to do a quadratic formula here. The one thing that's going to bind them both is the time. Time is the one quantity that will be the same for the both horizontal and vertical. So we have our cake formulas, or we could go from scratch and derive them, but what are the cake formulas? Do you know them without looking? Any of them?
Well, the displacement is like delta x equals the initial velocity times t plus the.
So delta x equals,
Whatever, initial velocity times t plus 1/2 acceleration, t squared.
all right, that's one. And just from a pattern point of view, there's two of them that are displacement, one that is velocity, and one that is speed squared, final speed squared. And again, one of the videos I talked about the fifth formula, but not really needed.
Isn't the first velocity one like basically the derivative of the position one, or the delta x? So it's like,
Oh, yeah, you can do it that way. I was thinking integration from the acceleration one, but if you do the derivative,
which is v plus acceleration times t.
v sub I, or O, whichever way you like it. All right,
V squared, I'm just reading this off of that sheet, but it's V initial squared plus 2a times delta x.
kind of multiplication.
Sorry,
What kind of multiplication?
I didn't know that there was more than one.
For vectors, there's two different types.
All I'm seeing is 2a delta x.
They don't have anything in between.
No, nothing's in between.
It's a dot. It's a dot product. And this one right here,
Was it, V final minus V initial over 2 times t?
close. Why would you divide by 2?
To take like the average.
Yeah, so how do you find an average?
Should be added.
Yeah, add it. You said minus.
Okay.
All right, so VI or VF, whichever one commutative property holds. VI, the sum divided by 2 times time. All right. So since we're trying to find time, we don't have enough information for the horizontal to find time, but we do have enough for the vertical information. So which equation do we use?
First equation.
All right. So I have negative 40 equals 18t minus 4.435t squared. If you want to take it step by step and do the 1/2 times, that's fine, but ultimately that's half of 8.87. Now what? How do you solve this?
Quadratic.
Okay, it is a quadratic.
Oh, I'm sorry, the quadratic formula.
Okay, what do we have to do before we plug in the quadratic formula?
Add 40 to both sides.
Okay? Or get whichever side you want to get it onto. Again, childhood scars. I'm going to put everything over on the left-hand side, so 4.435t squared minus 18t minus 40 equals 0. And so t 18 plus or minus the square root 18 squared minus 4 times.
program or calculators to do things like this?
Yeah.
Okay.
I don't know how to program those, so, but I'm assuming you do.
Michael was talking, he told me that he could show me how to do it, but he wanted me to ask first to make
Yeah,
sure.
I have no problem with that.
We're getting 5.65 for our addition value,
Okay.
and negative 1.595 for other one, so it's jumped.
1.595.
Mhm.
All right. Obviously, two answers. Which one do we want, and what do they mean?
The positive one.
All right. What does the negative one mean?
That's what would have happened if the ball had been moving before, sort of an arc.
All right. So we now have this time here. Gotten it already. 5.65. And so now we can figure out how far out it goes. And how far out does it go? Which equation would you use?
We could use the same one.
Yeah, okay. All right, so R equals 24t minus or plus 1/2 times 0 times, oh, we actually know what t is. So hopefully you recognize that is 0, which makes this very conveniently 24 times 5.65.
Which comes out to a clean 135.6.
And I'll spoil it, meters. All right, that's the basic projectile motion problem. That's in essence what you're doing on that lab. It just becomes more complicated as you throw in the error propagation. Oh, by the way, on the first lab, when I was grading them, the first two that I graded, it looks like the two people looked at the guide, or there were very few mistakes. It was really nice. So. All right, questions here? Because I'm about to make it more complicated. All right, so the problem has now changed. We're going to launch it at some angle theta, which I should actually normalize here. It's gonna land 135.6 meters from the base, and the question is, at what angles will this happen? There are potentially two answers. So, it looks like we don't have enough information. We do know something though. I don't know what the angle is, but what would the horizontal component be? Not looking for a number, looking for a small little formula.
30 cosine theta.
Yep. And technically, meters per second.
And then 30 sine theta.
30 times.
Sine theta.
No sign. All right. So we're left with this. We basically have, I don't know time. So if you consider time and theta as your unknowns, we have two unknowns, so we'll need two equations. If you want to consider final velocity, then we'll need three equations, but we really don't need to solve for the final velocity. But how do we solve it? What equation would we plug into? And which information would we plug into it? All right, so you're on